While frequency tables are a good first step to try and organize data in a way that is meaningful and useful, often it's helpful to take that frequency table and translate it into something visual. That visual would be a histogram. A histogram is made up of touching bars. We call them bins, that go over a number line. That number line is the x-axis that shows the frequencies. And those frequencies are the y-axis. So, for example, when we were working with frequency tables, we found information on time spent on homework. And we built this frequency table that had low values and high values and frequencies. And if you remember, the first class went from 1.5 to 5.5, and it had a frequency of 4. Our second class went from 5.5 to 9.5. It had a frequency of 9. Our third class went from 9.5 to 13.5. It had a frequency of 8. And our last class went from 13.5 to 17.5, and it had a frequency of 1. We can use this information to make a histogram, touching bars that go over a number line on an x and y axis. So I could draw my axis here, and my tick marks on the x-axis are going to match my bounds for the low and high values of each class. So we're going from 1.5 to 5.5 to 9.5 to 13.5 to 17.5. And the y-axis is going to be the frequency that they occur. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So I can see that the first class, which went from 1.5 to 5.5, had a frequency of 4. So I'm going to take the range from 1.5 to 5.5 and give it a bar with a height of 4. The second class went from 5.5 to 9.5. It had a frequency of 9, so I'm going to give that range from 5.5 to 9.5 a height that matches the frequency of 9. The next class went from 9.5 to 13.5. It had a frequency of 8, so the next bar I'm going to give a height of 8 that covers that range from 9.5 to 13.5. And finally, the last class from 13.5 to 17.5 needs to have a height of 1. Notice these bars touch each other. They go over the range on the x-axis that covers the range of the classes, and their height is the frequency of that range. Now, this graph is incomplete because any good graph will have a title, and a title needs to be more than just histogram. That's the type of graph. The title needs to say what information is in the graph. This graph information is the time spent on homework. That's a good title for our graph. We also need to label the x-axis. These values on the x-axis is the amount of time, and it's given in hours. The y-axis also needs to be labeled. It is the frequency for each of those ranges. And that completes our histogram. A few notes about the histogram graph that we made. First, it's important to note that the bars touch. This is probably the most common error, is students will put a gap between the bars. There is no gap between the bars on a histogram unless we have a class with frequency of 0. So a space would mean that there's a class in there with a frequency of 0. Doesn't happen very often, so usually their bars are always touching each other on a histogram. And of course, we have descriptive titles and labels on the graph. Again, a descriptive title and label does not mean we call it a histogram. Histogram is the type of graph. It needs to be descriptive. Tell us what information is in the graph. One nice thing about these histograms is they allow us to describe the shape of the data. Some common shapes that we see in histograms, what might be called a uniform shape. A uniform shaped graph has all the bars are about the same height. There might be a little bit of difference between them, but they're essentially all the same going across. That is a uniformed shaped graph. A second type of shape graph that's pretty common with histograms is what is called a normal shape, or often called the bell shape as well. The bell-shaped graph starts out small, and then the bars get bigger to the middle, and then afterwards they get smaller to the end. This shape's probably the most common shape that we see, although sometimes there's a bit of what we call a skew. A graph that is skewed to the right means that there's some extra data values off to the right that are keeping it from being symmetrical. So we might have something that's starting to look normal, but then as it gets shorter, there's a lot of extra shorter bars, or maybe a gap with a few extra shorter bars off to the right. And so it doesn't curve down as fast on the right side. There's a lot of extra stuff on the right side. That makes the graph skewed to the right. We can also see the opposite, and we can see a skewed left histogram shape. And a skewed left histogram shape is going to have the extra stuff off to the left. So there's maybe a few extra data values to the left before it starts getting into its mound shape and then back down. But you see all that extra stuff to the left skews it to the left. So if we go back and look at our histogram, it looks pretty symmetrical, high point in the middle. I might call this a normal bell-shaped histogram. The histograms are never perfect, but it does look like it's lower on the sides, higher in the middle, kind of bell-shaped. These visual representations of data are often a lot easier to see how the data is spread out.